All right, so again, as part of the data design phase, once you've gone through the requirements phase and the functional requirements, and you've gone through some of the architecture, and you're in the design phase, right? You're trying to identify what are the piece of information that you're going to be needing, right? What are the relationships? So commonly, the way that we capture those that information is through UML. UML is a unified modeling language, right? By modeling means that we want to formally capture some aspect of representation of the data, so that we can store, retrieve, and do some usable value, some predictions on how certain things are going to behave. Right? Presumably, a system is modeling or is simulating some physical phenomena, right? Either products, presumably whatever's stored in the system about a product is actually a physical product, right? It's some box that somebody wants to buy, right? And a user is actually physically some actual human being, right? So whatever our system does, ideally it's a simulation or representation of some real phenomenon, and it should be a fairly accurate representation of reality, in that we can run certain simulations, yeah, right? For us to be able maybe to predict how certain things are going to behave, whether I'm going to be out of a particular set of products, right? According to the trend on how things have been selling, it looks like I'm going to be out of this, so maybe I should order more, right? So those decisions on whether I'm going to order things should be an accurate prediction, right? That based on some reality. So we are as information scientists, we are the keepers of this information, and we ideally what's being simulated in our systems is reality, so that we can make real decisions going into the future. So anyway, so there's several approaches at developing software, right? Obviously. And they all typically start at a very high level description of the system, and whether you're the infrastructure and you're coding and you're using a particular language, Java, C++, C#, whatever, right? Typically, these would be derived from a higher level representation, typically UML, right? Through a class diagram, sequence diagrams, activity diagrams, and whatnot. That are then implemented at a lower level, Java, C++, C#, depending on the infrastructure that you choose. And same thing if you're doing it in a database, same thing, right? You would first start at UML, and then convert that into a lower level flat representation of that data model into SQL or ER diagram models and whatnot, right? Both of them start right at UML, right? So it's a nice abstract way of talking across multiple users the same language, right? Regardless of whether I do C++ and you do C#, UML allows us to talk the same language. So a couple of the terms that are used in object orientation, we talk about classes, we talk about objects. So object is right? It's a particular instance, right? That presumably represents something in the real world, right? Either an actual user, an actual project, an actual object, product, right? A particular chair, a particular table, a particular building, right? A particular university, and that has an identity that uniquely identifies us in the universe of things, right? So there's some identity to an object. It might change over time, right? You have an account, and the balance might change over time, but it's the same account. Right, so the state of the object changes over time, but it's the same object. Whereas the object might be made up of multiple values, right? Of my user, my NEU ID, my emails, my social security number, my current balance, and whatnot. And it changes over time, but those are values. They don't have an identity, right? They change over time, and they're transient. Okay, and classes is our capability of being able to identify that certain objects just are, then we can classify them. Well, we can say that they have similar aspects, certain similar properties, and that they should all have perhaps certain behaviors that go along with those properties. Object orientation made the important discovery or the important statement that it's a collection of both behaviors and data, that you cannot separate the two, right? That raw data has no meaning, right? Unless you give me a context, right? If I give you a random set of 10 numbers, right, you don't know what to do with them, right? Unless I tell you what they are. If I go and say, oh, it's a bank account, when then you say, well, then I can't really add a bank account to another bank account. That makes no sense. But if I tell you it's an integer, then it says, yes, I can add them. I can multiply them. Yes? So the context of what the data type is comes along with the behaviors associated with that piece of data. Right? So if I tell you it's an account, then you mean, oh, well, the behaviors associated with a bank account is that I can transfer, I can deposit, I can withdraw. I can't add it, I can't multiply it, I can't divide it. Right? It makes no sense. So until I tell you what it is, right? If it's the same 10 numbers as it's a flight number, or it's an ID for a car. Depending on those same 10 numbers, that raw data has no meaning until I give you the context, right? So classes is object orientation is one of the first ideas that that made this observation, right? That you can't data and behavior are married to one another, right? And we represent them in UML in this kind of like this rectangular representation where these classes have a name, right? Meaning that this is the archetype that all human beings or all buildings or all chairs or all tables or all courses or students or faculty, those are all the classifications that they have all the same attributes, right? And they have the same behaviors. And then we can go a little further and say what kind of accessibility do we have? Folks that live outside of the class or are inside of the class, what kind of accessibility do they have to the behaviors, or they have accessibility to the data that is stored in there? But that's really another idea of information hiding, right? So implementing certain good practices that we should minimize or at least control access to the data, right? Either through a set of APIs. But the raw data should never be made available outside. So these nomenclature here for pluses, hashes, and minuses or dashes represent the accessibility, whether they are public, whether they're available outside of the class, whether they're only accessible in a hierarchical inheritance chain, or they're not accessible at all from outside of the class. Right? So this nomenclature captures the methods, the properties, and also the data types that they either are capturing each one of these attributes, and also the return types of each. Plus, they would also capture the signatures for each one of these methods, names, and plus the data types that they take in. Right. So classes, attributes are the actual properties that describe the values, the values that describe the class. If you're describing a person, you might have a username, first name, last name, and whatnot, password, date of birth, and different data types for strings, dates. These data types not necessarily need to be any data type for any particular framework. Right? They don't have to be Java. They don't have to be SQL. They don't have to. It's kind of like a more generic. It could be even another class, right? It could be a data type that you declare. That you implement out of it, right? A new class, that's certainly a particular attribute could be of that particular type, right? Some of them could be a single value, or it could be multi-value, right? It could be an array, a collection, a list of multiple other instances of other data. So the attributes themselves could have multiplicity, right? So you can have multiple date of births, and maybe that makes no sense. Maybe lots of types of dates, right? Maybe the date that you were hired, the date that, obviously the date that you were born, the date that you were married, the date, several dates that might be associated with for a person. And you have multiple multiplicities, several multiplicities of capturing whether something is 0 or 1, maybe it's optional. There's a one-to-one relationship. This is only exactly 1. So this nomenclature means that the left-hand side over here describes the minimum value, whereas the other one describes the maximum. So between these two values, there's 1 to many, there's 0 to many. So 0 or more, and this is 1 or more. Typically 0 or more, it typically is abbreviated with just the asterisks. And 1 to 1 typically is abbreviated with just 1. Enumerations. So if a class or if a particular idea cannot be represented by any one class or any particular diagram that is from the standard UML set of diagrams, you can extend UML. Right? You can invent your own type of description. Right? So an example is enumerated data types. Right? There is no enumerated data type in UML. Right? So we can reuse other diagrams such as the class diagram, right? And reuse it in such a way that would allow us to represent enumerated data types. Right? So for instance, this is a class diagram, but we have used what are called stereotypes, right? And said, oh, this is a class diagram, but actually I am using it to represent something else. This is not a class, right? I am representing another idea, not a class. It's an enumeration. That means that these are the valid values, right? The only possible values for enumerated type movie genre. Meaning that if you have a variable of type movie genre, that variable can only ever have these 4 values. Yes? There are some enumerated data types that are standard. For instance, integers. Integers is an enumerated data type, right? It's an infinite enumerated data type, right? Going from minus infinity all the way to plus infinity. Yes? And those are the only possible values of 1, 2, 3, 4, right? For instance, 1.5 is not an integer, so it's not in that enumerated data type. I could not assign 1.5 to an integer. Make sense? So, but that's an accepted in a standard enumerated data type. Yes? If I want to create a brand new enumerated data type, I can use the enumeration stereotype and say that a variable of type movie genre can have only these 4 values. I could define a new one called big integer and then enumerate all the integer possible values. That would be very inconvenient. But you get the idea, yes? These are not properties, like in a class. In a class, these would be properties, yes? These would be variables with their data types, yes? Right? In enumeration, these are not considered to be properties. Right? These are considered to be just a list of valid values for any variable of type movie genre. And be careful. In the assignment, there are a couple of enumerated data types, and you are asked to use this format. Okay, don't use the square bracket and do the enumerated data type. You're asked to use this, right? This is referred to as a portable representation of enumerated data types. The thing is that enum is not necessarily implemented. It cannot be. Not all SQL vendors support the enum keyword, right? So don't implement it that way. You're asked to implement it this way. Okay. A specialization and generalization is the idea that multiple classes might share several attributes. Where, for instance, you might have the image widget and the heading widget, both of them having in common that they both have a name, they both have a width, they both have a height. So instead of replicating that over and over in both of them, instead you grab them and put them at a higher level class. Now this higher class, this base class, might be that you could actually have an instance of that class. So we would refer to it as a concrete class, right? So any class that can be actually be instantiated and represented in the UI or for computational reason, if it makes sense to instantiate it, they're considered to be concrete classes. Concrete classes don't have any stereotype. Right? They're considered to be all concrete. But certain classes might be a little bit too vague, right, to create an instance of them, right? Imagine you have a rectangle. You could certainly draw a rectangle. If you have a circle, you could certainly draw a circle. But if I go a little bit too vague and say that they're all shapes, and then I ask you to draw a shape, you won't know what to draw until I tell you what specific shape you want to draw. Right, so we would say that shape is an abstract class. Right, we cannot instantiate it. We can't do anything with it until you tell me about a specific type of shape. So same thing here. Widget might be a little bit too vague. So to declare them, to represent them and say that this is abstract, we would use the stereotype abstract. Okay, make sense? So again, don't forget to put the abstract stereotype in the assignment. Right? Multivalued attributes. So some languages allow us to represent multiple values for a particular variable, either as a list or an array or a set, so we could represent it in UML using square brackets and say how many of these instances could there be? 0 or more, or at least 1. Associations. So we can specify also relationship between classes and documenting what the association is from the point of view of that particular class. So we can say that authors writes books, right? Or books are written by authors. And typically we want to be as verbose as possible, right? From the point of view of that class, what is the type of association does it have between a binary association between two classes? Now, oftentimes we want to go a little further and specify more information about about that relationship. Perhaps we would like to capture, about how long did it take you to write that, right? Or how much were you paid for that, right? Or what kind of gratuities did you have, or and we would like to capture more information about that association, right? So we might have a separate class that has more information about that relationship, right? Typically, in a database, you would capture this relationship by using foreign keys and primary keys, right? And perhaps that's enough, right? It's that you might have just one author writes many books, right? That's all you need, a primary key and a foreign key. But if you want to capture maybe a history or more information about that association, primary keys and foreign keys are not enough, right? They only tell you about the relationship between one instance and multiple instances. So typically you would have perhaps a different table, right, that would capture some of that information. So in UML, you can capture that. Oh, here we go. In an association class that might capture some of the history about that relationship between these two classes. You still document it with a single line, creating the association, but with a dashed line saying what other information are you capturing about that relationship. Okay? So you might have several instances here about what did you write, what day, an edit log where you can like a source control and keep track of your progress, right? So there might be several instances here of this edit log. So association classes. Now this would be implemented in SQL, perhaps like a mapping table, right? Where you have one class here and then has multiple. You have foreign keys that go from this mapping table over to the other two. So going from this abstract notion of the association idea of UML and actually implemented it in SQL. Oftentimes we refer to that as reifying. to reify, to make a concrete implementation of something that is, represented in an abstract idea. So this is kind of an abstract idea, but you have to represent it in SQL, right? So the process of going from one abstract idea to a very concrete representation is reify. Now, you would reify this in Java in a different way, right? Because Java doesn't have foreign keys and primary keys, right? So each particular data model representation would have its own way to reify it, right? To make it concrete and implement it in that particular framework. Right. In the multiplicity, we can also annotate in the relationship between, or the association between classes, how many participate. We might say that 0 or more. If you give me an author, I will give you how many books that author has written. Or there might be multiple authors, right? One book written by multiple authors. So you can have many-to-many over here. So it would be fine to have a many-to-many. There wouldn't be a way to actually implement it in SQL, right? Of having two classes and somehow many instances of one table having associations with multiple instances in another table. There's no way to represent that, right? One foreign key can only point to one single foreign key. I can't point to multiple foreign keys, right? So to do that, you would have to, again, to reify this, you would have to add another table in between, right, that points to both of them. There's no way to implement this from the abstract directly to SQL. In Mongo, you actually could represent it straight, just from the UML, because in Mongo you can have an array, right, of pointers, or an array of indices that reference several other instances in some other collection, right? So this would have a one-to-one mapping into a NoSQL database, but it doesn't have a one-to-one mapping into a relational database, right? So the reification steps to go from this abstract notion into the different stack would be a little bit different. Yes. But you would always start from UML. UML would be the beginning step. So association class. So aggregation. So over here, also we want to capture what is the life cycle of those that are participating in a relationship, right? So for instance, if one instance, the lifespan of one record or one object instance depends on the lifespan of some other object, right? We say that there's a composition relationship between the two, right? That if one disappears, so does the other one, right? But if the lifespans are not related, right, that they're associated, but if one disappears, the other one doesn't necessarily need to be disappearing, right? We say that they're in an aggregation, in an aggregation, right? So, for instance, if we could decide, right, does it make sense that if a user, writes a whole bunch of blogs in Facebook, what should happen if that user, stops being part of that social network? What should happen to everything that person ever created in that social network? Who owns that, right? So if your business model says that if you leave the social community, everything will be destroyed, right? Perhaps that's what we would want, right? Hopefully that's what we signed for, and that we own our content. We can download all our content, and then they purge all their content from that. Right? So that then in the business decision, they would implement a composition relationship, right? We delete the record for the user, and that just cascade across all the other records. Everything is purged from the database. Yes. But instead, that typically what Facebook does is that even if you disappear, even after you're dead, your persona, right, continues after you, right? You're still in their system. They might remove you from records, perhaps, but they own the contents, right? So they might have chosen to have an aggregation relationship there. So here's an example of in our example of what we're going to be building throughout. if you remove a page in a web page, right, does it make sense to keep around all the widgets in there? Maybe not. Right? It might make no sense that if I remove a page to keep track of all the widgets in there. So presumably we might decide that we want a composition relationship there, right? That if I remove the page, everything will be cascaded down. That will remove also the widgets. Now, what about a website? If I remove the website, do I also remove the pages? Well, maybe, right? Maybe that might make more sense. But what if I have multiple websites that are maybe sharing across? Maybe they all have the same login. Maybe they have the same registration. Maybe have multiple things that are shared across websites. Right? Do I want to remove it? Well, maybe not. Or maybe I want to have maybe a higher level meta website, right, from which all things are derived. So again, deciding on whether things continue or not, depending on the lifespan of one, is either aggregation or composition.